Okay, so tonight we're going to talk a little bit about some React best practices, um, clean code versus dirty code, um, just some general things that I've seen out there from reading some of the more well-respected React people on the scene. I don't prescribe to think that any of these are really my original thoughts, the things that I've curated just from staying in the scene and keeping up with people smarter than me. So if you have any questions, comments, anything, feel free to just shout it out and throw it out. I'm just going to go through some things, show some examples, and yeah, hopefully this is good and worth it. So let me know. So first thing is, why do we care about clean code? So it's a style of programming, a consistent style of programming that is going to make our code easier to write, read, and maintain. Often we'll spend some time working on a problem, we'll figure out something that fixes that problem, and then in a working environment, we'll submit a pull request to the repo through whatever version control system that your job is using. And then the concept of clean code is that just because you fix the problem and the code works doesn't mean that you're done with your code. Before submitting that pull request, the idea of clean code is going back through and removing code that does nothing, dead code, or refactoring some, or removing any commented out code that was in there, or your console logs. Really thinking about and asking yourself, will someone else be able to understand this code 6 months from now? And it takes some practice to really think about what somebody else would be able to understand from your code. Something that you'd be really proud of. And why do we care about this is because, as we've heard many times in the curriculum, if, I'm assuming everybody's in the React curriculum by this point, we're good developers, we're lazy. We want to find problems that occur more than once and automate or write solutions that will be more efficient, so we don't have to write the same thing over and over and over again. So clean code will actually help us with this, because if you haven't been in a working environment yet, if you write code that's dirty, quote unquote dirty, that isn't using best practices, that is too all over the place, isn't doesn't have the commented code cleaned up, things like that, doesn't have dead code cleaned up, after you do a pull request, you're most likely going to have a code review from someone more senior to you, and they're going to come back and say, hey, they're going to point out all those things, and you're going to have to go back and fix it all. So it's actually going to be more detrimental to you, and you're going to have to go back to it and spend time and write it again. Then you're going to have to update that pull request, and then they're going to come back and review it again, and you're going to go back and forth more than you would have to if you just took the time at the beginning before completing that pull request and double checking your code after you've made it work. So clean code should pass the quote unquote smell test. And that is something that, you can just look at it and say, something's not quite right here. With that, if it doesn't feel right, it probably isn't. That doesn't mean that you necessarily always know exactly what the answer is, especially starting out. I know I submitted some pull requests and specifically put in the pull request, I know this section of code isn't exactly where it needs to be, but I'm not sure exactly how to do it. And having that awareness as we're starting out, or as you're starting out, is something that is will take a little bit of time, but I think we can all sometimes look at something and just be like, I know something's wrong here, but I'm just not sure what. So if it feels wrong, then pause, take a step back, and 9 times out of 10 we'll be able to figure out something else that's better. So one thing about good code, or best practice, or clean code, is that it's dry. And we've all heard dry, don't repeat yourself. So if we're doing the same thing in multiple places, we can consolidate that code. If you see patterns in the code, that indicates something is great or prime for drying. So sometimes this just means literally looking, sliding back, zooming out from your code and looking at it, especially with code highlighting, syntax highlighting. you can see those patterns a little bit easier. So let's start doing some or showing some examples. So let's look at something that'll be dirty. So let's create a component in React. And let's say, div. Close that up. And let's put another component in there. Give it a type, class name. Let's give it some props. And all right, so I think we could all see that, this is not the best way to do this. We're literally only changing one character between these two components. And some refactoring would probably be in order. This might be the best way to write it first and fix the problem and get it working, and then stepping back again and saying, okay, I need to clean this up. So something that would be cleaner would be, let's say, my other component. This is going to have a prop passed to it. And let's say other component type equals type. Class name colorful. And then we'll have props like before. Okay, and now if we were to do my component, oh, that's probably yelling because we're using the same component twice. That's fine. Our div. Let's just put a 2 on here. Equal. Oh, no, that's yelling because of the missing arrow function. There we go. Okay. And then let's make sure all this. All right, there we go. So surprisingly, I think something that we would think is counterintuitive, but by drying our code up, we actually increased its size. However, by doing this, we've increased the maintainability of our code. So it's going to be easier to work with in the future. And that is something that we want to make sure we're thinking about, is maintainability in addition to, as maintainability as a component of clean code and following best practices. So be warned, and remember that you can go too far with drying up code. There's lots of things that are repeated in code constantly. So making sure that you have a good scope of what needs to be dried up and what doesn't is also something to be aware of. Don't get too granular when you really get down to it. That can be detrimental. And I think that's one of those things that's kind of a code smell. If you feel like you're getting way too in depth on it, you probably are. So another aspect of code that's clean is it's predictable and testable. So testing is becoming something that's more mandatory than not these days. It's one of those things that people, don't want to break things that they put into production. And obviously we can't just click around on a website for every single thing that we want to test every time we make a code change. It's not efficient. It's also something that is prone to human error. So let's let the computer do what it's good at and have it repeat the same exact steps every single time to make sure that our code is working right. So that is something else that clean code is good at. Another considered best practice is that clean code is what's called self-commenting. So let's say you write some code and make sure that it's fully commented. And after some time, you find a bug and you go back and you change the code, but then you forget to change the comments as well to reflect some new logic. So maybe that happened, maybe it didn't, maybe you remembered to, maybe you didn't remember to. But however, if the next person who ends up looking at your code, because once we get outside of our schooling here at Flatiron, we're going to be writing code that multiple people will look at, and people will look at in the future after we've written it down the road, they might get stuck because they focus on the comments and go down a rabbit hole trying to figure out why this isn't working, when in fact it's something that was changed in the code and the comments weren't updated. So commenting is really good, in my opinion, inside of code. However, it needs to be done in the right way. So adding comments to explain complex thoughts, that is, things that aren't obvious. Fewer comments will also reduce the clutter of the code. So let me add, as I'm adding a comment, let's put a little kind of header there. Let's call this one commenting. Let's do our dirty example. And some of these things will build on each other as we go. So here, we're creating our fetch user. We're going to fetch, and with that, just make some URL users, string interpolate in that ID. So then let's convert it to something else. Then validate user. Okay. So some comments for this could be get user record from API. Oh, another line. Convert to snake case because it's coming to us in camel case. And then make sure the user is valid. So this is showing kind of, these are pretty straightforward. Like, I think most people are going to understand when they see fetch, or can figure out that when they see fetch, we're fetching a user. That's the name of this function. So we're hitting a REST API, what it looks like. So we're getting the user by the ID. I meant to make this convert. We're going to convert it, and then we're going to validate it. So these comments might be redundant, maybe too much. And so let's clean this up. Still same function here. Wait. These need to be. I think I had that wrong the first time. Maybe not, but either way. Fetch, we're gonna hit the same URL. Let's just copy this. All right. Then we do something like this, snake to camel case. Then validate user. The one thing in our process that might have been a little bit obscure would be what that convert format was doing. So now we know exactly what's happening, and the code is basically commenting itself. So we don't need to add comments to it. This is called snake to camel case. We know that we're taking, after we get this, we're changing it from snake to camel case. I guess this is, I'm getting things backwards. Camel case. There we go. And then we're validating the user. So this is the example of self-commenting, where the code is basically commenting itself, as opposed to having to add comments afterwards. So another thing that is considered a best practice would be how we name things. This is coming, and all of this is coming from a blog that I read by Donovan West, which I'll share the link to at the end. I just didn't want it to be a distraction looking through it while going through this. And Donovan West is Director of Engineering for American Express. He really knows his stuff. I've read him, and I can't remember the name of the guy, go back and forth on a pull request for the React core repo, which was very informative. Reading to really, really smart people debate topics of React, but I digress. So he has some very specific ways and opinionated ways, but I think very well thought out ways for naming things. So with naming things, talking about variable names, function names, and even file names, but being very specific in how things are named. So an example being something like setting up this function or setting up this variable. Where done is going to be when current is greater than goal. So Donovan asserts that Boolean variables or functions that return a Boolean value should start with is, has, or should. So we can see the difference here if we do, let's say we name this is complete. And that just is forcing us to think in the true or false, or yes or no aspect. So done doesn't force that in our brains, in English at least. So if we said is complete or is done, we're going to think yes or no. So if it's Boolean, now we're enforcing a yes or no answer just by the name of the variable. So when we see this somewhere else in our code, let's say it's up here in this other component being passed, as a prop is done, we know it's going to be Boolean. And that's just from seeing it other places. And a lot of these naming conventions really help when you're deeper into code and you're using a variable that you can't see where you got it from, or a function and can't, you don't want to have to scroll back. So when you look at the naming convention, if you're consistent in it, it's very helpful. So functions, he asserts, should be named for what they do, not how they do it. So in other words, we don't care about the implementation in the name, because the implementation of the code might change at some point in time. So like fetch user. We don't want to know fetch user, let's say, from REST API, because what if we change the API and now we're using, a GraphQL API? Now our name doesn't make sense. So we'd want something like fetch user. Excuse me. So for another example, this can be similar, but like load config from server. That's telling us too much about how this is happening. That we're loading the config from the server, when all we really need to know is that we're loading the config, because everything after inside here could change. We could do this differently throughout time. It could be, we could be using a jQuery AJAX call, or we could change it to fetch, or we could do whatever. But now we know that load config will always be consistent for what we need. Naming wise, that is. All right. So, get rid of this. Another thing that quote unquote good, clean, best practice code is going to do is follow some proven design patterns. And these are things that you learn over time that you've seen over and over and over again. And that's because, or if you've read in books, there are solid design pattern books out there. You might think, what can a book from like the 70s teach me about, writing code today? But computers have been around for a while. I think we know that. And throughout the years, programmers have developed certain patterns that solve certain problems. And they've found the best patterns to solve certain problems. And these are called design patterns. So there are ways that, have been figured out over the years that are the best ways. And these are things that, we shouldn't try and reinvent. They've been, debated and figured out way back in the day or through time. And these are the design patterns that we should follow. And then there's also, best practices like what we're talking about, which are sort of like design patterns, but a little bit broader and not as specific. They're typically a little bit more opinionated. Rails is a prime example of best practice. Rails believes convention over configuration. Rails has an entire manifesto that you can read that DHH writes and updates strictly about, what it considers best practices. So things like you should link your code, or how to include dependencies in a library, things like that are considered best practices. So a couple of best practices for React applications are using small functions, each with a single responsibility. And I think we teach that well, showing, presentational and container components, and really targeting exactly what we want one component or function to do. And this is the single responsibility principle, something that we teach and Flatiron teaches from the beginning, ensuring that each function does one job and does that one job very well. So this could mean breaking up complex components into smaller ones. And this will also lead to better testability. Testing a function or a component that does one thing is much easier than testing all the different options within a more complex component or function. Also, don't try and impose your internal requirements on people who consume your code. So this one's a little bit more abstract. Leaky abstractions, things that you believe or understand or kind of get, and imposing that onto others. It's kind of what will happen to us as juniors. People will impose their abstractions on us and kind of force us to work within those things. It's not always the best practice. However, starting out, it's kind of, I think, where a lot of us will be. It's good to fall into it because I think a lot of it, while it might seem like a person's own opinion, is actually going to be more of a best practice than we think. Another best practice is following linting rules of whatever project or team you're working on. So this will not only make the code clean, it'll catch a lot of bugs before they happen. Linting is built in. And I'm throwing errors now, and you see the red squiggly lines, and it'll tell me that there's supposed to be a corresponding closing tag for my other component, and saying, oh, we're missing the closing. So not only will it help catch bugs and help you write cleaner code, it'll also lead to more consistent code. So like one thing that, if you've noticed, I've been putting the semicolons at the end of everything. That's because the last, I'll share them, Alexandra. The last company I wrote React for used Airbnb as a style guide. So everything had the semicolons at the end. So I got used to that. And that is consistency. That means that everyone on the team is writing code the same way. So when we were doing pull requests, when we were doing code reviews, when I was jumping into someone else's code that they wrote, it all looked the same and followed the same coding style. Something that might be a misconception is that following these best practices is going to take you longer to write your code. And it may seem like that is true, that it'll slow productivity. And initially, doing these things may take longer. However, as time goes on, these things will result in speed improvements and speed ups in writing code. And that's because the time spent fixing comments or being down here on line 60, say, and needing to go back up and seeing what a poorly named variable actually is or function actually is and parsing it, those things will end up speeding up the process. It'll take some time, and yes, making more modular, smaller functions and smaller components will take more time than building massive, large components. However, there is some strength in being able to write something and never having to touch it again, because it does what it does so well, and it's solving that one problem. And then the kind of write it and forget it, so to speak, functions and components. So let's look at a couple more examples. So this is going to be a little bit more in depth, and it's probably going to not like some of these things because, well, maybe it won't. Maybe it will. So we're going to write that. And then let's set up a div. Another div. Then our description. Then let's close everything off. And now also, I like having that space there. Okay. And now we have our div. And then let's say title value equals title. Any questions? Everybody keeping up while I'm typing this out? Just copy this one this time. More examples. Okay. So here's a code sample, and taking a look at it, just more in general, you know, not even looking at the words, just taking a look at the pattern, at the shape of things, at what's going on here. Looking at it, we notice, you know, they're exactly the same, except for that title. So this is just another example of something that we could dry up. So let's see what would be a good way to do that. So this might solve our problem, but we'd notice, okay, we can make this better. Let's say dried up. So I'm actually going to copy this and then just edit it. Let's import description, and let's pass children. And here, we'll put that in there. We can leave that stuff like that. And then with our title, use some mass assignment or mass assignment object destructuring. I always get the two confused by their name. So here, let's do, we're going to call that thingy component. And actually close it there. Okay. So this is probably a little bit more abstract than most of you have seen, or maybe not. We're doing a few different things here. But really what we're doing is we're tossing this component in right here where children is, because this is a child component. It's inside of this parent component. So children, this is being rendered right here for children. So pretty much inserting this title right here. This way, we're not repeating all that code. It allows us more flexibility. It's going to allow us it's going to allow us an easier way to refactor this as well. So another best practice in React that I think is covered very well in our curriculum is the stateless functional components. They're introduced in React 0.14.0. Before, I guess, they decided to just jump to 15 and get rid of the 0 dot. But they're used, to greatly simplify render-only components. And not everybody uses them yet. Some people really just, I don't know why, don't like them. I refactored many components into stateless functional components in the past, but you'll see things like this. This would be old code because it has a table in it. And this is prime to be refactored. Not only do we clear a lot of clutter, but we're eliminating table row complexity that is introduced by using our class. We have this table row, and then our children. So those are functionally equivalent. We can see how a stateless functional component is definitely cleaner and simpler to look at, and I think makes for better maintainable code, easier to look at code. Yeah, it's something that a lot of legacy React code doesn't have, because going back and refactoring it all takes time. However, also sometimes people don't start introducing them. They just stick how it's been before, instead of saying, oh, there's this thing that I can do. As far as I understand at this point in time, stateless functional components haven't been completely optimized by React, but Dan Abramov has said that they will be in the future. So it's a win that's coming. A lot of people say that they see performance improvements by using them, although React does convert them back to classes, to my understanding. So that could have changed in React 16. I haven't been up to date on it as much as what the changes have been. So that could be different, but it is supposed to come down the pike. And some people do say that, they do see performance increases by using stateless functional components at this point in time. So that's another win on that side. So something that started in ES7 is REST and spread. So let's look at this. And this is taking on object assign and making it simpler to use. So let's go back to our my component. We're going to pass some props. Oops. And with that, let's say equals. I'm going to add some things to that. Oh, that's not how we return. Return div. All right. And then this is, I think, kind of, going to the nth degree of an example. Yes. So now with the rest and spread syntax, we can do that much simpler. We've already seen this once by passing others, and that's our spread syntax there. Class name. So what's happening in this first one is with rest and spread, we're able to basically, through rest, we can basically pull this class name off of this object that's passed into it and continue passing the rest of the keys and values of that object without that class name attached to it. So we're saying, okay, take off the class name and continue passing the rest of it down in others. And this spread, you can look into it, it's basically just a whole bunch of equals. Kind of like, if there was a title, it's doing title equals title. And then, the next thing. Just much more succinctly. So rest and spread, we take the rest of the properties and then we spread them, little word games, as new props to this other component, my other component. So rest and spread are definitely some new best practices to follow, keeping things a lot cleaner. Things make more sense. We don't have to make a variable and then delete one of the properties from it and then pass them and create things like that. Let's see, what else do we want to go through? Might be two other things. Okay, let's look at or talk about destructuring. Object destructuring and array destructuring. Yes. So there's another component above a parent component that is passing props as, you know, it could be a JSON hash or something, you know, that's coming down. And that has something like, let's say, like, you know, props equals some JSON hash. I'm completely screwing this up, I think. You know, colorful title, lovely color, right? And then, yeah, we're calling, you know, my component I'm passing all the props to it. And then inside of here, we're saying, okay, let's pop off the class name. And now this others is just going to be these two, because we've pulled out the class name by doing this and just left others. Does that make sense? Yeah, I'm just trying to say that these props here are an object of some sort. So I was trying to give a little example of a hash, JSON type hash type of thing. Because a lot of times the props are going to come as the result of an API call. So most of the times you're going to be dealing with props that are a JSON, or your state, which is, you know, an object. So yeah, let's look at destructuring. And we'll finish up with this. So ES6 introduced the concept of destructuring, which is a best friend, I think, and a lot of people believe is, because it allows us to do what we were just looking at, it to pull apart properties of an object or elements of an array. So let's look at, let's say object. Excuse me. So component. So let's say we have our component will receive props. We have new prop, and, you know, this set state. Say active. This. I don't know where it's expecting another semicolon, but it's probably because this is supposed to be inside of a class. And let's look at a better way, or a cleaner way to do this using object destructuring. All right, so component will receive props, and let's pass it that active prop. Now we can simply do active. So in this first example, component will receive props is passed the new props, and then actually props. And then we set state.active to the active prop, to the new active prop. And then in our destructured version, we destructure new props into active. And then we no longer need our reference to new props.active, but we can also use the object property shorthand in set state. And this is just going to do it for us. So I know it's a little bit abstract, but look a little bit deeper into it. It's not as, I think, as out there as it might seem. And now let's look at array destructuring real quick. And then I will show you the VS Code plugins, that extensions that I use. Although I'm going to have a bunch that are not needed for what you guys are doing, unless you're doing some things that are completely not in the curriculum, because I have extensions for that stuff. So this is something that's a lot of the times overlooked in ES6 because people use objects so much. But let's say let's split. We have language. And country. So this, we're taking a locale array and we're splitting it on, this is like language country. Like locales are things like, if you've ever seen them. That type of thing. And this is kind of the example that we're looking at. So in this case, we're just looking at the first one. With ES6, we can do this and array destructuring. We can set those two variables like that and initialize them. And then it'll automatically assign them to the first and second elements of this array that we've split. It's really neat and cool and powerful. It's something that a lot of people don't ever use. And yeah, that's the, I think that's the time. Don't run away just yet. I am going to